Now, welcome to our electrical energy management. So, in the last lecture, we were discussing about the demand side management. The demand side management is nothing but the modification of consumer demand of electricity through various methods such as financial incentive and consumer education. So, already we have discussed in detail, but just as a highlight of last lecture, either if you want to do the demand side management or energy management, it is necessary to give some financial incentive to the consumer, and in addition to this one we have to give some education, we have to guide to the consumer how to reduce electric bill by ethical way in view of environment, in view of sustainable development, this one. Now, usually the goal of DSM is to encourage the consumer to use less energy during the peak hours or to move the time of energy use to the off peak period. So whatever the energy consumption, either we have to reduce the energy consumption by doing some energy conservation program, by adopting some energy technology, that is using some energy efficient electrical gadgets or machineries are there. We have to replace old machinery which is in it is not efficient. It replaced by the new machines which is available in the market with the BEE mark, Bureau of Energy Efficiency marking is there. So it may be a 3-star rating machine, it may be a 5-star rating machine, or we have to reduce the energy consumption during the peak period. So peak period into 24 hours, there is a two peak periods are there. One peak period is evening 6 p.m. to 10 p.m. and the second peak is 9 a.m. to 12 noon. So if you are reducing the energy consumption during that time, definitely our electricity bill is there, will be smaller, which already we have learned in the TOD tariff, time of day tariff, which is implemented by the MSDCL to give some financial incentive and financial say burden if you are using more energy during the peak period, and we have to move that load to the off peak period. So what is our off peak period? From 10 p.m. to morning 6 a.m. So if we are shifting our load which is has a less priority or which is not necessary to run in the daytime, like electrical like a water pumping system, effluent treatment plant, it may be some cold storage unit. If you are shifting such type of load in the night time, definitely we are able to reduce our electricity bill, and it is nothing but the financial incentive. Second is the consumer education. So consumer education may be carried out by the tariff itself, because tariff, as soon as the electricity rate increases, all type of consumer try to reduce their electricity bill by reducing the consumption, by reducing the wastage, by reducing the energy consumption or day or lighting load in the daytime, and so many points they may consider. And second way to do the energy consumption, to do the energy consumer education by conducting some awareness program, conducting some training programs in the different type of consumer, definitely it will help to do the or to implement the demand side management. So now the need of the DSM is that if you are going to save 1 unit of electricity, the meaning is that you are going to avoid 2.5 time of the capacity addition in the power plant. The same things we have already carried out. The meaning is that if you're doing the energy conservation or demand side management, definitely we can avoid the additional capacity or additional installation of the power plant, or we may postpone that installation of power plant, which will help to the society, or because it requires a huge amount of investment for erection of power plant. It is found that roughly if you want to increase the capacity by 1 megawatt, there is a 6 crores are needed for the installation, and 3 crores are needed for the transmission and distribution network. Now, if this is the some need and importance of the demand side management, now who demands the electricity? Definitely the consumer. So it is necessary the demand side management can be achieved by service provider, that is the franchises, distribution franchises. It may be MSDCL distribution, it may be a somewhere Tata Powers, Reliance Power, or other power grids are there, or it may be a state electricity boards are there, are should be equally participated by the consumer. So it is a equal participation from the consumer and the utility, then and then it is possible to achieve the demand side management. Now this is the some one load curve is there. It found that only 3 to 4 hours the load get increases, whereas the rest of the time load is will be smaller. So the base load will be small, is comparatively smaller with the maximum demand. So that maximum demand is occur only 3 to 4 hours, and therefore during that hour, that to fulfill the demand of the consumer, utility has to provide by adding some generating facilities, by starting some more power plant. It may be a pump storage power plant, it may be a diesel power plant, and therefore the load factor will be smaller, and it will gives the generating cost is somewhat higher because of the smaller load factor. So if you want to improve the load factor, definitely the the difference between average load and maximum demand should be as small as possible, and it is going to occur only when your load curve is somewhat flat, or it is it does not has a large difference between the maximum demand and average load. For example, in this curve, if this curve is like that, so this load is no doubt it is going to increase somewhere, it will increases, but the increase in load is not so high, and it is like that one, where my cursor is there. So if suppose this is the load variation is there, this is the change in the load, again there is a small, and instead of that much peak is there, a small peak will be there. So definitely the curve what somewhat will be flat, and the load curve load factor will be near to the unity. Okay, so now it is this is the things, the observation is same which we have already discussed. Now, thus the utility will always to try to encourage the consumer to use less energy during peak hours. This is our objective of the demand side management. And if the consumer using less energy during the peak hours, and that process or that using less energy during peak hours is known as a peak sleeping. The meaning is that what we are doing, we are reducing our maximum demand. The suppose if you take the same load curve is there, if we are reducing that maximum demand by shifting some of the less priority feeder to the night time, reducing or just switching off the pumping load during the maximum that is the peak hours. So what will happen, we are curtailing some of the load during that period. What is the period? From the 17 hours to 21 hours. If you are reducing the consumption by switching off less priority feeder, for example pumping load we have stopped, effluent treatment plant we have stopped, or other some which is not necessary to run during that time, it can be shifted to the night time. So if you are curtailing the load, if you are reducing that load during that time, peak time, then it is called as a peak sleeping. So this is a one method to reduce the maximum demand is known as a peak sleeping. Second is that if the consumer are shifting to the off peak period, or where the load is smaller, that is called as a valley filling. So somewhere in the load curve there is a hills are there, and somewhere there is a valleys are there. So instead of switching off, directly switching off, one way is the switch off the less priority feeder, that is a pumping load, effluent treatment plant, you are just stop for the 4 to 5 hours. Sometimes it doesn't matters, you are stopping it. Okay, but if the load on the effluent treatment plant, if the load if we need a continuous water pumping system, cold storage system, so what we can do, we can shift this type of load into the off peak period. So this is your peak period and this is your off peak period. So shifting that load to the off peak period, so what we are doing, we are filling that valley, we are curtailing the hills, we are reducing the hills and filling in the valley. So that is called as a valley filling. So if the consumer is going to shift their load to the off peak period, it is called as a valley filling. So this is the very popular method and very effective method, which it does not compromise the quantity, quality and comfort level. Only we are shifting the less priority load, less priority feeder to the off peak period. So this method is the very effective tool for the demand side management. So one is called as a peak silping and second is called as a valley filling. So because of this mutual benefit, or we can say that uh, both are participating, consumer also participating in fulfilling the demand, and utility is also helping by giving some incentive in term of electricity bill. For example, the electricity rate is smaller from 10 p.m. to morning 6 a.m. So it is an incentive. If the consumer consume more energy during the peak hours, they are imposing some penalty, that is the electricity rate will be higher one. So this is the best compromise between the utility or distribution company as well as the consumer, and by mutual understanding between the utility and consumer, definitely we can achieve the fruitful result from the demand side management. Okay. Now what is the benefit of demand side management? This benefit is similar to the energy conservation benefits are there. So again we will recall that one. We have a customer benefits are there, utility benefits. Utility is nothing but the transmission company, distribution company and generation company. So it is a completely it is a utility, and the social benefit, society as a whole. So satisfy the electrical demand because of uh, doing the energy conservation, doing the energy management, demand side management, every type of consumer getting energy 24 hours. We know that last 10 to 15, it may be 5 to 6 year back, continuously there is a load shedding period is there in the residential area, commercial area as well as the agriculture sectors. So everybody, every type of consumer suffering because of the load shedding. So the production get decreases, isn't it? And at the same time, it will affect the comfort and quantity and quality of the product. So consumer is not satisfied. But if the utility and the consumer do hand to hand practice for the demand side management and energy management as well as the energy conservation, so it will satisfy, the utility is able to satisfy the electrical demand to the all type of consumer. So we found that nowadays the power is available for the residential area 24 hours. Only the power is going to fail or there is a shutdown only because of the some maintenance work or some force outage is there, or it may be some fault in the system. Otherwise there is no scheduled load shedding is there. Earlier there is a scheduled load sheddings from 9 a.m. to say 12 noon, there is a load shedding in that area, then after that the second area. So it is the scheduled load sheddings are there, but there is no schedule such, there is no such schedules are there. Only the power fails only because of the fault, only because of the maintenance work. Second benefit to the customer is the reduction is reduce or stabilize the cost of electricity bill. Now here the cost of electricity bill is going not going to increase. The electricity bill is going to increase because of the new power installation. Definitely it requires some huge amount of investment, and when there is a huge amount of investment, it is going to take from the loans. So we have to pay the loans, and definitely it has to be recovered from the different type of consumer. So if there is no such expansion in the system, definitely the electricity price somewhat will remain constant, even though the price is going to revise every year or sometimes in the two times in a year. Maintain and improve the lifestyle and the productivity. So definitely we can improve the lifestyle, we can improve the uh, our productivity. So we are sure that the power will remain same, the power will be present over there. So we will do the work very smoothly, isn't it? We do not want to shift our schedule as per the availability of the power supply. The farmers are ready to irrigate their land as per the times. It is not to be shifted to the night time, isn't it? So there is a lifestyle will be a better one. if we do the demand side management. So this is the advantage of demand side management to the customer side. Now from the utility, lower cost of service, definitely when we are reducing the demands, the meaning is that we are reducing the reactive power, we are reducing the load on the system, and because of this one, the we can say that the maintenance is going to will be smaller, isn't there? Is no failure, there is no overheatings are there, so the lower cost of service is there. Okay, second, improve the operating efficiency and flexibility. Definitely when the continuous powers are there, they are not bother about it, there is no under some pressures are there, therefore they can improve the operating efficiency. At the same time, there is a flexibility, so in each and every feeder the power is available, so because of some maintenance and because of some force outage is there, they can shift the load to the different feeders, because everywhere the power is available, there is no protocol for the load sheddings are there, and hence it will improve the operating efficiency of the system. Now, improving the customer service, definitely the customer service is going to improve. The people those are working in MSDCL or the people are working in the distribution company, they have a less burden over the load shedding, and they can work for the customers. They can improve the customer service because of the availability of the power. Now, so societal benefits are that reduce the environmental degradation. We found that if you do the energy conservation, or if you do the energy management or demand side management, definitely we can avoid the additional installation of power plant. When there is no additional installation of power plant, we are effectively utilizing the existing infrastructure. Definitely it will reduce the degradation or of the environments. Means we do not want to erect one more plant, there is no acquisition of land, isn't it? There is no construction of dam, or we are not using any type of nuclear material or nuclear power plant which may damage, or there is a hazards are there. So such type of it is a benefit for the environment. Conserve the resources, whatever the resources are there, we are going to conserve. We are using less coals are there, isn't it? It producing less heat, so we are let less water resources are going to utilize, so it will conserve the natural resources. Protect the global environment, so as a global environment issues are there, it can be protected. So this is the benefit of demand side management, and it is quite similar, or it is say similar to the energy conservation benefit from all three categories. Now we will try to understand how to do the demand side management and their response. DSM consists of two major components: demand response, part of load management. So demand response is nothing but the part of load management, and energy efficiency, which is also considered as a conservation. So only to do the demand, to do the management of the demand is not sufficient. Whereas we have to understand the demand response, or we have to implement to the demand response, we have to reduce the maximum demand by curtailing the load, shifting the load, educating to the consumer. At the same time, we have to think toward the energy efficiency of the system. I will give the example. Suppose in your colony, everyone is utilizing the LED light and CFLs are there, isn't it? The 18-watt CFL or 18-watt LED light will give the light output which is equal to 100 watt your incandescent lamp, which we are using earlier. It is a simple filament lamp is there. If you measure the illumination level by 100-watt lamp, and if you measure the illumination level by your CFL of 20 watt or LED by the 20 watt, the light output is same, isn't it? If you want the comfort level, that is the light output should be same, and everybody has replaced their CFL lamp or LED lamp by the incandescent lamp, what will happen? Definitely the load is going to increase. Everybody is replacing their 18-watt lamp by the 100-watt lamp, and collectively the load is going to increase on the transformer, and it is may found that your transformer will burn out. Why? Because load is get increases. So we have decreased the demand on the transformer. It is similar to decreasing the demand on the generating plant. So we have decreased the demand over the transformer by using energy efficient electrical gadgets. So energy efficiency is a very important tool to obtain the demand side management. Okay. So one is to control the maximum demand by shifting the load, by switching off the load, by other methods. But the major component or the second major component is the energy efficiency, to adopt energy efficient machineries, to adopt energy efficient lighting system. Then and then it is possible to uh, do the proper demand side management. Okay. So this is the two part of the demand side management. One is the demand response and second is the energy efficiency. Definition of demand response: change in the electricity usage by end user or customer from their normal consumption pattern in response to the change in the price of electricity over the time. What is the meaning of demand response? The demand response is the modification of load of the consumer with respect to the change in electricity prices. When the people think toward the energy conservation, when the electricity rate roses, okay, or it increases, isn't it? The rate is increases. How it is? Suppose the rate is 2 rupees, nobody is going to care. I have to do the energy conservation. But as soon as the electricity rate is 7 rupees per kWh or per unit, definitely everybody going to think that what would be the way to reduce the electricity bill. He is going to replace by incandescent lamp by the CFL lamp, isn't it? They are going to replace their old fan by the BLDC fan, which is only the 28-watt 5-star rating fans are there. So when the people are going to think toward the energy efficiency and the energy conservation, only when the electricity rate increases. So the demand response is the change of electricity use by the consumer from its normal consumption pattern to the new response with reference to the electricity bill. So this is called as a demand response. Are you getting me? So it is quite clear. Where the electricity rate is very small, nobody is going to think toward the electricity consumptions are there. Okay, how much we are going to use the electricity. But as soon as the electricity rate increases, everybody going to think, or everybody is going to modify its electrical demand or electrical energy demands with respect to the energy conservation, with respect to the electricity rate. When all the industry going to think that I have to, or they have to shift their load to the night time, when the rate is going to decrease in the night time, or going a rate is going to increase in the daytime, then and then the people are going to shift their less priority feeder in the night time. So this type of education, this type of implementation is given by the utility in the electricity tariff. So to do the energy conservation, to understand the energy consumption, to understand the demand side management, it is very much necessary to understand the electricity bill, especially for the HT consumer or for the industrial consumer. If you are able to understand what would be the rate of electricity in the different slot of time, definitely one can do the a proper way of energy demand side management. Okay, so this is the meaning of demand response. Demand response: electricity consumption can voluntarily trim their electricity use during the peak period and choose to use electricity at the less congested time. So it is a what consumer can do: voluntarily he will shift the load to the off peak period. So whatever the peak period is there, uh, he or she, or say consumer, is not going to use electricity, or either they will trim the load, they will curtail the load, and it is use some less congested time. The meaning is that it is the off peak period. Okay. Electricity utilities provides incentive. it, they are going to provide some incentive to reduce the consumption during the peak period. The utility, what they want to decrease the maximum demand. Otherwise, if one of the generators get overloaded and it get tripped from the system, definitely whatever the load on the generator is, it is going to transfer to the other generator. Now the next generator also become overloaded, again second generator is going to trip, and it will give the cascade tripping. So it is very much important for the load management engineer to control the maximum demand, and it can be done by giving some incentive, giving some penalty to the consumer in the electricity tariff. Okay. So incentives to reduce the consumption during the peak period, and it is the residential consumer, commercial and industrial. Everywhere we will find some incentive. What is the such type of incentive? If the consumer consume less than 100 unit, the rate will be smaller. But if the consumer consume more than 100 up to the 300, the rate will be higher one. So this is one type of penalty, one type of, one side it is a benefit, and it is the block rate tariff. Commercially, if the power factor is low, you have to pay the penalty. So it will decrease the kVA demand by the consumer, and it is going to consume from the resource itself. So they have, or consumer has to say install capacitor to improve the power factor. For the industry, the electricity rate will be higher from 6 to 10 p.m., and whereas the electricity rate will be smaller from 10 p.m. to morning 6. So the industry should, all the industry should shift their load, less priority load, to the night time. Initiating the demand response by manual, it may be consist of manual. As soon as in the daytime load is increases, they will switch off the some of the feeders. Automatic, we can install some demand controller, which already discuss. Semi automatic, because in case of automatic, it may found that sometime the very important work is going on and you have switch of the supply. So it may be some kind of semi automatic is there. Some part is manual, some part is automatic. We can do the demand response. So load management as a demand side. So direct load control, we can directly control the load. That is nothing but, the best example is the load shedding, isn't it? Utility has a control over the different type of feeders, and they are directly controlling, they are directly switching of the load in the peak period. Local load control, local load control from the consumer side. Consumer can do the peak seal peak, he can reduce the demand. It may, the one may do the valley filling, it may curtail the load in the maximum period and it will shift to the night time. So from the consumer side, it is a local control. Strategic energy conservation, so we can do the energy conservation. Every type of consumer, if adopt the energy conservation program, or it is a skill. So definitely load shedding, flexible load shape, we can change the load shape, we can shift to the some type of work into the night time. Say if it is an industry where raw material can be processed separately and it can be transferred for the final product. Okay, some of the things, some of the process is that the raw material, as soon as finished its process, it has to be transferred for the final one. So here the load cannot be changed. But the first industry where raw material is processed and it is stored somewhere, then it is transferred for the manufacturing. Here the flexible load is there, and definitely where the flexible load is are there, such type of industry can do very easily, or we can industry can shift the load uh, anywhere in the 24 hours. Tariff option, it is a very good option. If the tariff is used in such a way that which will increase, the tariff is going to teach the consumer how to do the energy management, which already we have discussed in detail. End use energy conservation, so this is one more important, which is the second part of the energy management. One is the demand response. So from first point to the electric tariff is the demand response, whereas end energy conservation or energy efficiency from the second, improving the efficiency of various end users. By using energy efficiency appliances, better housekeeping, and reducing energy leakages, this is important for the agriculture where energy efficiency is very low, only 30 to 50% are there. So it is found that the energy conservation program or energy demand side management is very much lagging in the agriculture sector. So now today we will stop here. In the next time we will see the method of how to do the energy demand side management. Okay, so thank you.